In my view, the building industry is in a crisis in this country, and we are not attracting talent. We are not attracting young people into the trades because they don't see it as a path toward a strong future. And that is a true mistake because it is so much fun. We all started with Legos, so everyone knows the building is fun, and it's so flexible. And truthfully, and I loved what was said earlier, I don't look at climate change as a crisis. I look at it as an amazing opportunity to single-handedly solve multiple problems, from social equity problems to climate justice problems to our environmental crises, and ultimately to help us lift one another up and solve this crisis together so that we rethink how society is functioning. And I think the building trade is a huge piece of that equation.
Now, for the second part of this morning, we are going to have 6 10-minute presentations followed by audience question and answers. And so this is sort of the practicality of going all electric and how we can and are already building more sustainable buildings. And so I hope that we can all be inspired by the work of our colleagues. And our first speaker today is Kent Gonzalez from Northland Development, to give us a developer's perspective on all of this. So welcome him up, please.
What I want to talk about today is our little project in Newton, the Northland Newton Development, and how we became electrified. There's a lot to talk about, as I said, and since I only have 2 minutes, I have to leave out a lot of really good stuff, the stuff you can't make up, so I can focus on our sustainability journey. And one thing you'll see as we go through this, there was a slide in the earlier presentation of our project, and hopefully if you remember that, you'll see some differences. But for those of you that are not familiar with the project, this is Needham Street, this is Oak Street, this is the historic Saco Petty Mill building, formerly the headquarters of Clark's before they moved to Waltham. This is Marshall's Plaza, which many people may know that more than anything, but there's 22.7 acres here. These are old industrial buildings. Everything is going to be demolished as part of the project, except for the historic Saco Petty Mill. And then for you architects, this is the Channel 7 Tower, which is 1 foot shorter than the Eiffel Tower and taller than the Chrysler Building. And that's not even the tallest tower. There's another taller one. So this slide illustrates the development program that was approved by a supermajority of the Newton City Council on December 2nd, 2019. That's after 3 years of intensive community engagement, the last year and a half of which was the formal review process involving the City Council, city staff, peer reviewers, city commissions, city boards, individual citizens, and community groups. I'll be talking more about one of those community groups, Green Newton, later. Is anybody here from Green Newton? I'm going to be nice today. Very nice. So currently the project's on hold. If you haven't heard, even though we got approved by the City Council after a long, arduous process, an opponent group was able to gather enough signatures to put the project on the ballot for reconsideration by the entire city, and that has been scheduled for March 3rd. So the entire city will vote on whether to uphold the City Council decision or to overturn it. So we've put everything on hold because we're just sort of, we're superstitious and don't want to move forward assuming that we're going to get our approval. So key aspects of the project include 800 rental apartments, of which 140, not 123, will be affordable, and which begins to fill a very large void in Newton in terms of affordable housing, and also provide a new wide diverse option for a wide variety of housing products. And the project is about 35.2 units per acre, which makes it the 6th or 7th most dense project in Newton. And a concern, but it's really not even the densest project in Newton. Of the 22.7 acres, 10 acres or more, 10 acres or more than 40% of the site is open space. There are 7 parks, including the Village Green. There's a community splash park and community playground here. This was a community building, but at the last moment, of negotiations. The city didn't want a community building. They wanted the splash park and then a neighborhood park. So we didn't argue. And this area represents a restoration of the South Meadow Brook, which is exposed. It's actually encased in a culvert as it comes through the site and actually goes underneath the Saco Petty Mill here. And one of the things, I don't know if you can notice, but the Saco Petty Mill will have a new entry, glass enclosed entry here off of the village green. We're only providing one parking space per apartment unit, whether it's a studio, a 1-bedroom, a 2-bedroom, or a 3-bedroom, which in this market is unheard of. So here's the real focus of today's discussion, our sustainable design strategies, of which building electrification is really only part of that. The very nature of the project, a mixed-use, walkable, village-oriented residential, retail, and office neighborhood is really the overriding sustainability strategy that we really pursued. We have a robust traffic demand management program that includes a free shuttle to the Newton Highlands T-stop running every 10 minutes, 7 days a week, 16 hours a day. Hopefully this will encourage people to either leave their cars at home or not even own one. There'll be over 1,100 bicycle parking spaces. The list goes on and on. And as you can see along the bottom of the slides, we have quite a cast of characters or consultants, if you will, and this isn't even all of them. We have 3 different architecture firms, and if you have a sigh of sympathy, that would be appreciated. 3 different firms. Cube 3, SGA, and Stantec. But luckily we have one MEP firm to keep them all in line, AHA. The core of our sustainability team is Michelle Lambert, who's here today, Lambert Sustainability. We affectionately call her Mother Earth. And like a good mother, she is annoying in her nagging and persistence that we pay attention to her about how we should design with climate change as a primary parameter. And like a good mother, she was always right, and like a good mother, you don't mess with her. So as part of our community engagement process, we reached out to many community groups, including Green Newton, an amazing organization of very smart, respected, and dedicated climate change warriors. We were excited to meet with them to review our LEED-centric sustainability strategy. We are very proud that we had committed to LEED for Neighborhood Development certification for the entire site. I believe this would have only been the 3rd or 4th LEED ND project in the state. And then we were also committing to LEED core and shell certification of Petty Mill. And then LEED certified. So Bob Andrews from AHA, our lead administrator, and I were very pumped up to meet with Green Newton. Should I switch to this? No, yep, okay. So we met with Green Newton, and we were very pumped up to meet with Green Newton because we were so proud of ourselves being with our LEED-oriented strategy. So we met with them. They weren't impressed. They were gracious, but they were not impressed. So we're saying, well, wait a minute. But what they did, I only have 2 minutes? Oh, I got a long ways to go, sorry. I'll try to speed it up. And I practiced, really. So basically, they told us LEED doesn't really address energy. So what Michelle did, she reached out to Stephen Winter Associates, one of the, if not the premier passive house firm in the United States. And they became an integral part of the team. Dylan Martello from Stephen Winter held a Passive House 101 class with our entire design team using one of our buildings as a case study. So to date, we've committed to design and build 3 buildings totaling 280 units as Passive House. 5 others totaling 478 units are being analyzed for Passive House feasibility. The remaining 42 units would be located in the 4 3-story buildings around the edge of the site. These are the smaller, more traditional townhouse type projects. And you can see here the Passive House buildings that are in the darker color. And then this is the core group of the additional 5 buildings that are being analyzed. All of our buildings will either be Passive House certified, Lead for Homes multifamily certifiable, or both. 3 members of our team have become Passive House certified, and 1 more is taking her training next month. We expect more to follow. So this is a view of what the project will look like when it's completed, if we get approved. The Sacopeti Mill, the Village Green. This is one of our Passive House buildings. This is another Passive House building. This is another Passive House building. And this is really the cluster of 5 buildings that are being analyzed right now. So now I just want to summarize what we see as the challenges. Not barriers, but just challenges that we all need to be aware of. And some of them have been discussed today. So I'll try to do it in negative minutes here since I'm out of time. Rapidly evolving green building systems. Well, there's so many systems. I think everybody knows this, but it'd be nice if they could be coordinated, particularly with the energy code. There are 2 different Passive House systems that argue with each other. LEED is constantly evolving. There's LEED for new construction. There's LEED for multifamily high-rise, mid-rise, and they're even thinking of changing that. There's the energy code, and now we've got local ordinances that are trying to legislate green building standards, but not all of them are as reasonable and well thought out as Brookline's. And under Brookline's, our project wouldn't have had no problem. Experience and expertise. This has been talked about a lot. We simply need more experience and expertise in design and construction. There's just not a lot of people doing this. There are only 2 contractors that we're aware of with direct experience at the scale that we're dealing with Passive House, and only one of them has done a market rate project. Mass Save, however, has launched programs to help alleviate these shortages with multiple training programs and in some cases funding assistance. Now, here's the bad word, gas. Well, so far at the scale that we're developing, gas we just can't find a feasible solution that works for us, a feasible electric solution for domestic hot water. So what we need to try to do somehow is find a way to future-proof our buildings so that when electric comes feasible, we can then convert. But again, it's still open territory. How do you prepare for that? Materials and systems availability. We need manufacturers of all building materials, especially glazing. Market rate developers are big on glazing to come up with better glazing systems, whether it's dynamic, triple pane, however many panes. Then mechanical systems. I have a letter here, which many of you may have seen, that was sent out in January from distinguished engineering firms, AHA, BR+A, WSP, Vanderweil, the list goes on, asking manufacturers to really ramp up their ability to, or ramp up their design to come up with more efficient mechanical systems. Cost premiums. Well, we hear a lot about this, but frankly, there hasn't been enough in our type of project, in the larger scale market rate projects. There hasn't been enough of them built really to understand what the cost premiums are. That's not stopping us. We just need to be aware of that going into this process. And Mass Save also has financial incentives available to developers for helping them with feasibility studies, modeling, and then also incentives for the number of Passive House units that you create. And we're taking advantage of this program, at least to this stage, and plan for the rest of the projects to take advantage of it. But so far, they're funding our feasibility studies. Now, this is one that a couple of architects might disagree with me on, but the architectural character of our buildings. This is something that we're very concerned about. This Passive House favors a very simplistic envelope, and we'd like to think that we'd like to provide a more provocative envelope. So since I've been told to stop about 4 times, I'll conclude by saying, from our perspective, the path to electrification is the path to take, but with our eyes and our team's eyes wide open on how we can really effectively and feasibly do it. But we are committed. So thank you very much. And sorry for taking too much time.
I want to talk about Passive House as, from my perspective and the perspective of many, the perfect baseline for future electrification and for net zero. I'm not going to delve deep into the standard. I think I'm talking to a very experienced audience. So my goal today is to talk about how you actually execute it, because it's one thing to design it and it's another thing to get it built. This is a picture of FINCH in Cambridge. This is where it was probably 2 months ago. It's well under construction, getting ready to be occupied in April. 98 units of affordable housing, intended to be Passive House certified, pending blower door testing in a few weeks. There have been a lot of reasons lately why Passive House has been really moving quickly in Massachusetts, and they're all very exciting on the incentive side of the equation. Thank you to Mass CAC, if you're in the audience, for focusing on the affordable housing equation. Thank you to the EAC and the Mass Save program for bringing out these incentives at the end of last year. We are seeing a surge of folks looking to understand whether it's feasible and to at least take that first step of the feasibility study. And frankly, that's kind of a no-brainer from my perspective. And there are, as we see, lots of policy shifts that are moving us in the right direction, not quickly enough. This is what our energy model tells us we are going to achieve at FINCH. It obviously has some assumptions baked in. A lot of those are in the design. How much insulation do we have? What are the U values of our walls, windows, et cetera? What's the occupancy? All of that data. Those are sort of things that we've baked into the design. Some assumptions always on plug loads and hot water usage. The one thing that's also intended and assumed in the model is a certain infiltration rate, and that's the one thing that we know we have to test for to verify that we've executed properly. And that's really where I want to focus our conversation today. In my view, the building industry is in a crisis in this country, and we are not attracting talent. We are not attracting young people into the trades because they don't see it as a path toward a strong future. And that is a true mistake, because it is so much fun. We all started with Legos, so everyone knows the building is fun, and it's so flexible. And truthfully, and I loved what was said earlier, I don't look at climate change as a crisis. I look at it as an amazing opportunity to single-handedly solve multiple problems, from social equity problems to climate justice problems to our environmental crises, and ultimately to help us lift one another up and solve this crisis together so that we rethink how society is functioning. And I think the building trade is a huge piece of that equation. So what did we do with a builder who had never designed or had never built a Passive House before? Because as was mentioned, there are only a handful in the state who have done so. One of those was on our first Passive House project, the distillery. And a lot of the ones who build at scale are really new to this. So there is a learning curve. We have every ability to do it, but we have to think about how we communicate and how we collaborate to make it an effective process. So our first step on the job site was to develop a poster that I have no idea was impactful in any way or not, but we thought we needed to just put a message out there in multiple languages that made people think, even if they had no idea what we were talking about. And this is the signage that we installed around the job site. Certainly, we were looking to be very, very clear in our drawing sets. A lot of our drawings need to be printed in color to articulate what should be clear to the builder and to understand what products are being used where. We spend a lot of time thinking about the sequence and which thing has to happen first to make sure we can get that continuity of our air barrier, of our thermal envelope. But, you know, many people looking at this are it's not gonna be crystal clear. There's another piece of the equation, and that's what happens when you're out in the field and you start to see things coming together. And so NEI is our contractor, and they have been phenomenal, a phenomenal partner, a true partner. And we instituted at the very outset of the project, in addition to that 3-week look ahead that's sort of traditional in a construction process, some time in advance of our job meetings where we would look at that look ahead understand what passive house specific details were coming down the pipeline in that next few weeks and which trades were going to be involved. And we would get those foremen into a room with us in the GC, and we would look at those details. And it's a humbling experience when people who actually build the details look at the architect's details and say, you can't build that. And so it was a true iterative process to reinvent detailing based on what we're seeing in the field, based on the sequence, who's got to get in there first, who's got to get in there second. I can't figure that out on my own sitting in my office. That's a team effort. And we were lucky to have NEI on board during sort of the design phase to help do a lot of that work with us early. But there's nothing like standing out on site and looking at a detail that's two-dimensional in our drawings and way more complicated in reality, and thinking through that process. Craft. Building is a craft. It should be considered a craft. And if we begin to value it again and to treat the laborers and the trades with the respect that they deserve to create the future that we're looking for, then we need to bring them into the picture, and we need to really acknowledge their value. And I think that is a huge mind shift that we need to all start bringing into our conversations. So I made it a point on this project to get to know the name of all the key foremen and all the key people who were involved in the things that actually make this a passive house. This is Kaio's team on the carpentry side installing our air barrier. And I will tell you that we do mock-ups for window mock-ups and just general mock-ups on all of our projects to make sure everyone understands how the details are going to be executed. An air barrier is not that hard to install on a flat surface with tape. It's a lot harder to install at the windows, at the doors, at the transitions. And so our whole team, including our verifier and our QA/QC folks, our commissioning, our envelope agent, sat for several hours as we watched Kaio's team installing that first window. And it was painful. It was not easy. It took a lot of time. And in the end, our verifier took us aside and said, Michelle, if this is what it's going to take on every window in this 98-unit building, you're never going to get there. You're never going to get it in time, and it's not going to be the quality you need. So this is the air barrier we're using. This is not the air barrier we started with. I think it's really important to see it in process, and I can tell you that they love this product, and they are feeling really excited about how excited we are. We also have to have our eyes on things. Different teams come on and don't necessarily get the benefit of the chain of communication that has happened prior to their arrival. So, we can clearly see there's a little too much air there on our exterior wall for an airtight envelope, not to mention insulation issues. So you've got to kind of keep on that. Similarly, our QA/QC team was very focused on our insulation and making sure it's not pinched and it's really filling the cavity, and we're getting, again, the continuity that we're looking for. Sequence matters. It's really, really important, and it gets way more complicated than we sometimes realize in our office. So it's important to talk through that. And just to note that airtightness is not just about the exterior envelope. It's also about compartmentalization, particularly in a multifamily setting. So different trades, working on the inside than working on the outside, didn't get the memo. So we had to have the same learning curve a couple of times. This is Ian. Ian was responsible for making sure that all of our penetrations in the slab over our totally unheated garage were airtight. And we can see that the first try was not optimal, but Ian is a quick learner, and all he needed to do was be shown how to do it right, and he was able to execute that beautifully. Same thing with the insulation. How are we insulating around that? You've got to think through this. What's going on around the fireproofing? What's going on in these gaps? That's Eric's team. He is in charge of the MEP and all of the duct work that's going in. And Eric's job, he doesn't need to know about passive house. He just needs to know that his duct work needs to be tight. That's his job, and that's what we're expecting, and that's what we're going to ask him to do. So it doesn't have to be a complicated conversation. It just needs to be clear about our expectations and the fact that we're going to be testing to help make sure that we catch problems early and we support him in achieving what we're looking for. Always great to see that it does make a difference. This is from the inside without continuous insulation on the outside, and now with continuous insulation. And finally, it's just really important to note that this is a team effort. It really, really is. It's certainly changed a lot in the time that since I began working in this field. And those teams take a lot of expertise and they take a lot of collaboration. So no one is alone in this process if we really look at ourselves as collaborators and consider, again, the craft of building. Thanks. And now I'm going to introduce Jacob Knowles.
Geez, I have to go after the Passive House project. You're not going to like this next one. So you can see there's a lot more glass on this building. This building has a long history. It started many years ago when KPMB, the architect on the job, won a competition to work for BU, and it was at the president's level where they were inspired by this iconic architecture that was going to be a beacon for the future of BU's computational and data sciences program. And so from the very beginning, this was a glass building, and that was non-negotiable. The project then went on hold awaiting fundraising efforts and internal approval process within the university. And when it came back to life, BU had really transformed from maybe a little bit more of a laggard in the climate action front to a truly inspiring institution that has made huge headway, including, including, not that I had anything to do with it, but including entering into a long-term power purchase agreement with a wind farm developer in South Dakota. And so they are offsetting 100% of their campus electricity consumption with renewable energy, selling that back into the grid in South Dakota and using their utility bills on campus as a hedge against the fluctuations in that market. And there's other institutions that are doing similar things like that. The great thing about doing it in South Dakota is it's a very high carbon grid. And so purely from a carbon footprint perspective, they're having a huge impact, actually offsetting more carbon than is the impact of their low carbon electricity consumption here in New England. So there's a big debate about what is net zero? Is that acceptable? Does it need to be in your same grid region? So we welcome you all to that conversation. So in any case, there's this weird contrast between a demand for an all-glass building and also demand for a carbon neutral, 100% electric solution. And so we had been pushing sustainability from the beginning, but when BU kind of flipped the switch and said, all right, let's do this, we were up to the challenge, and it was a great team to work on this. So the new codes, by the way, are starting to tighten the parameters around envelope performance. And you can no longer have a double glazed, highly glazed building and then offset that with a very efficient mechanical system. The code says, nope, envelope has to pass on its own. This envelope almost meets the new code. It's triple glazed, highly detailed, deep insulation on the overhangs and so forth, but this is something that we look to as a precedent now for other large commercial real estate projects that need to meet the new envelope code requirements that will be mandatory by August 7th. So in addition to having an envelope that essentially meets the new code and uses triple glazing, we incorporated some pretty advanced mechanical systems. And there's two big advantages to some of these mechanical systems. One is they're much more efficient. So we're recovering energy and we're making sure we're just supplying heating and cooling and ventilation in just the right amounts to each zone. But in addition to that, they're actually smaller. So what's the advantage of smaller? Well, so not only are they less expensive to build, but you save on the space that you would have had to build to house the bigger air handlers, the bigger plant. And so when you look at all of that savings, that's how one can justify financially the reinvestment in some of the more expensive pieces like the geothermal system. So in this case, we're not going down 500 feet with our geothermal boreholes. We're going down 1,500 feet, so 3 times as deep. And we're using a proprietary concentric pipe product rather than the typical U-bend. This sends the water down inside of the inner pipe, which is insulated, and then it sends it back up the outer pipe, which is then conductive to the ground. And so you get even better performance out of this system than a conventional one, and it can handle that pressure of that deeper borehole. So the reason why we went so deep is because we needed to engage with the ground to have enough heat exchange, rejecting heat in the summer, pulling it back out in the winter to heat the building with our heat pumps, rather than using fossil fuels. The reason we had to go so deep is because we had very limited space to work with. and we still needed a large amount of mass of rock to engage with. And so there's just a small alleyway behind the building and a pocket park, and we actually put 3 of the boreholes beneath the footprint of the building itself. So in all, we have 31 boreholes at 1,500 feet deep each. So this is all projected energy performance. The building broke ground in December, so obviously we'll have to see how it performs in real world. But a conventional design, you can see code minimum at the time that this was permitted is on the left. Our proposed design, which again, as one maybe reduce the window to wall ratio, you could get even better. They're also installing solar on campus. A portion of that solar will be allocated to this building. That gets us down to the green bar. And then with the South Dakota wind energy offset, that's how we're getting to carbon neutral. And there is no gas connection to this building. There will not be any gas consumption. And what did it cost? It cost less than 1% construction cost premium. As I mentioned before, smaller systems, smarter systems, saving on space, you add up those 2 savings and it pays for the geothermal, which is the one sort of major cost premium. Overall, roughly balancing out. This was one of the projects that was used as a case study in the USGBC Massachusetts, now Built Environment Plus, report on the cost of getting to net zero, and the payback is less than 2 years. So it meets pretty much anybody's pro forma, even a developer type of pro forma from a cost effectiveness standpoint.
Big Meister is a residential remodeling firm. We work on existing single-family and small multifamily homes. We don't do any new construction except for the occasional addition. How many people here live in a single-family or a small multifamily 2 or 3 unit building? All right, these 10 minutes are for you. I was thinking during the presentation at the beginning with Jesse and Lisa, you had talked about the questions that you got. You know, what does this mean for me? You know, what does this mean for my home? Big Meister's based in Newton. I live in Newton. I think our building stock profile is probably fairly similar. We have a lot of existing small single-family, small multifamily housing stock. And that accounts for about 1/3 of our overall emissions in Newton. So we really have to address these buildings. Up until a couple of years ago, we had electrified 2, maybe 3 single-family homes. These were, and small multifamily. These were homes that we had done deep energy retrofits on, so they're super insulated, really low energy homes. And starting about 2 or 3 years ago, we began to electrify much more broadly, electrifying many more of our projects, sort of moderate energy performers, even energy hogs, incorporating partial or whole house electrification into these projects. And I'm just going to give you an example of give you a couple of representative projects that we have done in the past couple of years. This is a house where work is just wrapping up. It's in Jamaica Plain. The renovation scope would have fallen below 50% of the floor areas renovated, would have fallen below that 75% threshold. In fact, all of the projects we did in 2019 would have fallen below that threshold. This was a house that hadn't had work done in decades, so there were a lot of opportunities on both the envelope side as well as on the mechanicals. Old boiler, no central heating, very old hot water heater, so old in fact that our plumber actually took a photo of the hot water heater. You know, you don't encounter those every day. There was a lot of opportunities. The project is now nearly, I'd call it a near whole house conversion. So we have heat pumps for heating, heat pump water heater, induction cooking. There is an existing gas dryer that the owners will replace with electric when it finally dies. This project we considered, there's no cooling. The owners really wanted to add cooling, and that's one of the things that when we're thinking about converting homes can be sort of a trigger, pushes people over the edge. So they're going to do a heating system upgrade. They're going to add cooling. And from a first cost perspective, once you're there, then heat pumps are heat pump, a ducted heat pump, or a combination of ducted and ductless is not going to be all that much more. So that really put us over the threshold. And also the home, people have talked about incentives. The home MVP program, which is a pilot energy efficiency program running sort of in parallel to Mass Save right now, really made, there were significant incentives for the conversion to heat pumps that helped make that project possible. This is a house in Brookline that was completed in 2018. Again, the renovation scope would have fallen below that 75% floor area threshold. Slightly more modest energy scope. There was already a fair bit of existing insulation, so the insulation, the envelope work was restricted to the spaces we renovated: kitchen, dining room, family room, bathrooms, mudroom. This project was going to start it off as a partial conversion to heat pumps. There was an existing furnace and central air located in the basement, and comfort complaints, particularly during the summer, on the second floor. So the original plan for this project was to install a ducted heat pump air handler in the attic to serve the second floor, so to sort of take that off of the existing system. And then about a month before we were supposed to start, their central air broke. And so that, for this project, is sort of, that's what tipped us over into, and this is a theme that I'm going to return to, that rather than sort of the floor area, what sort of is a trigger in all of our conversion projects has to do with the age, the efficiency of the existing HVAC equipment, whether it's time to upgrade that, or whether there's also comfort complaints. And so cooling, the lack of cooling or insufficient cooling plays a role. All right, this is just a final example of a project that just finished up this fall in Newton. We've done a handful of whole house conversions, and that JP project and the Brookline project are two examples of homes that have gone all electric or nearly all electric. But we're doing more of what I would call these partial or phased retrofits, where as part where it makes sense, given sort of the homeowner's priorities and sort of a long-term energy plan for the home, to implement a conversion to heat pumps over time rather than all at once. And so for this project, had a hydronic heating system and central air. Again, there were comfort complaints that the central air, which was located on the third floor, wasn't serving the first floor very well. So we did, as part of this work, actually ductless heat pumps for the first floor. And as part of the planning, we talked about that the long-term goal would be to move over to heat pumps eventually. And actually, it's looking like we're going to complete that conversion for the second and third floors probably sometime this year. We did not remove the gas water heater, although we will likely do that as part of the phase 2 heating conversion. These are very highly motivated homeowners on an energy efficiency and carbon perspective, but they insisted on keeping a gas range. And we do run into that. I could go, this is a sort of a special case when I don't know, I haven't gotten a warning yet. But so this is a 3-generation house. And the grandfather, the parents of the wife are Chinese, and the grandfather did all the cooking. Before we did this project, he was outside in the winter with his little walk burner setup so the kitchen was done for him. And so we had to give him a very a professional gas range. All right, zooming out, big picture, looking back at the projects we've done over the last year. We did about 20 projects. None of them, as I said at the beginning, would have been subject to the bylaw if the bylaw existed. We did, of those 20 projects, there were 8 heating system upgrades. All of those upgrades were either partial or whole house conversions to heat pumps. So 0 gas systems installed. And I was thinking in the car on the way here, I bet it's been at least 3 years since we've installed a gas system. We've extended some gas systems, but I'd have to go back and check that. I didn't do that. 11 kitchen renovations. 6 we were able to convert to induction, and 5 retained gas, despite the fact that our default, our starting point in all kitchen renovation projects is induction. So then if, you know, we don't start with, oh, you have your choice. We start with, this is how we do things. But we don't draw a line in the sand. We don't say, sorry, we're not going to do your project if you insist on having a gas stove. People want to know what these conversions mean for their overall energy use, carbon emissions, and energy costs. This is the Brookline house that we have a year's worth of post-project data on. Very substantial reductions in energy use and carbon emissions. Energy costs went up. And Jesse talked about that a little bit, the expectation that whether costs go up depends on what you're comparing things to, but in a retrofit situation, when you're going from gas to all electric, I would expect that the costs increase unless you are at the same time super insulating the house. Lessons learned. Electrification is practical for many more homes than gut rehabilitations, many more retrofits. It's not all or nothing, and in fact, phasing the electrification often makes more sense. And we are very lucky to work with people who take a sort of long-term stewardship approach to their homes. Key factors, obviously in the absence of a mandate owner commitment. I should add here what I mentioned previously, that incentive programs can really be a significant factor as well, and we're for that one project in JP. The age of the equipment and whether it's meeting people's comfort expectations. Cooking can be an obstacle, and costs for gas-heated homes may go up. And that is it. And now I'm going to introduce Martine Dion.
So I'm Martine Dion. I'm the Director of Sustainable Design at SMMA. I'm going to give you an overview of one of our net zero school projects. We have about 3 or 4, depending on how it goes through design, net zero ready, net zero public schools. The Wellesley Honeywell Elementary School project is a 78,600 more or less square foot elementary school. Wellesley has neighborhood schools. So this is a feasibility study that we did over the past year and a half. And I must say that we've had a wonderful collaboration with the town of Wellesley for the past 12 years. 12 years ago, we designed their high school, which really revealed that community's vision and commitment to environmental leadership. So it was wonderful to start this project. And in fact, the town had put in their RFP their EUI goal, which we felt was very reasonable. And I think that's a great way to set the tone from the start. And from there, we engaged into a feasibility study process that has an educational scope, that has other elements. And the net zero energy was not something that was aside. That was something that was fully parallel to the process. So town meetings were not specially for net zero. It was the feasibility town meeting that covered all the scopes, including net zero. We held many workshops. We did eco charrettes, which usually in a public school project, we only do a little bit later in the game. Now, for us to do those schools, those net zero schools, we need to do this up front. So this was a precedent, and it set a precedent, actually. One thing I want to mention is that particular school is not going through the MSBA process. It's going to be fully funded by the town. But the town has another project that's going through MSBA. So this set the template for the other project. We did also a good amount of analysis, which I'll talk in a minute. And what I want to talk about also is we partnered with Bill McClay, architect. Some of you may know how Bill is an expert with net zero energy. Specifically, he brought his expertise for the financial analysis. We did our own energy modeling. And it really provided a great sort of complementary expertise to the feasibility study. So when you go through a feasibility study, you go through many many iterations. You can go up to 20 or 30 different design options. We modeled between new construction and renovation addition. We do look at keeping the school if possible. In this case, the majority of the school was in bad shape. There was a small historical part, a small existing part, I'm sorry, that represented about 15% where we considered, the town considered keeping it. So we modeled both options and both preferred option of these two approaches. Even with the existing, we were able to stay within and below the 30 EUI. That existing building, we could do retrofit to the roof, retrofit to the glazing. There were some limitation to the enclosure, which is enclosure retrofit, which is why there was a little bit of a penalty between the two. So this shows that ultra low EUI is achievable with these projects. This has a kitchen. This has a cooking kitchen, gymnasium, all the elements of a public school. And then we went into a little bit more detail. And we did really our due diligence because when we transition, and I think we're going to face this in this movement, when we transitioned to an all-electric, we have all-electric system, all-electric heating and cooling. We have generations of building owners, building managers, facilities managers that are used, a little bit like the plumbing, piping discussion that happened earlier. They're used to those systems that are existing now. And so, and in some cases, they've experienced the air source heat pumps or the geothermal heat pumps very, very narrowly. And in some cases, there are older technology that didn't work as well. So there's a lot of education to do there. So we ended up doing 6 energy models for 3 different HVAC systems, both for the new option and the reno option, comparing them both on the EUI and cost. And one of the goals of this project was to show the feasibility, the cost feasibility, the first cost and the operational cost. So I'll talk about the first cost in a minute. For the operational cost, we were looking to be cost neutral. So if you look at, if I can do this right, if you look at the air source heat pump, the operational, predicted operational cost is pretty much equal to the conventional. However, the conventional gas system, gas heating system, does not meet the RFP requirement for EUI. This is modeled based on the current code, the code that's not fully issued yet, that somebody mentioned earlier, that's supposed to be issued this week. It's approved, supposed to be issued this week, and it would go in fully mandated in August. So this is based on that. So that EUI, Wellesley is a stretch code town. So that EUI represents stretch code level natural gas heating, and it doesn't pass what was mandated in the RFP. So the project is likely to go, we're in schematic design right now, is likely to go with the air source heat pump. So we're looking to be operational cost neutral, but one thing I want to say is the existing building has an EUI of 103. It's costing annually about $82,000, and it's 36,000 square feet. So it's half the building we would build. So this building is obviously going to improve at many levels on the operational level. In terms of the first cost, we established, and again, this is very early feasibility, but the incremental cost was less than 1% of the construction cost. And the payback was a few years. Now, the bidding market right now is not on our side, and there's a lot of projects that are coming back much higher, so that 1% could increase. But that said, even if we go to 2 or 3%, we made the calculation, and that's still within a 10-year payback. And we're building this building for 50 years. So very doable, I must say. We're designing a few other projects. I have about 2 minutes left, so I'm quickly going to show you again how feasible this is. We're about to start construction on a 165,800 square foot elementary school, net zero with a 1.4 megawatt photovoltaic system. And that's happening, going. And then one other school we did, which was not net zero, MSBA LEED V4 Silver School, tight budget in a very economically challenged community. We did MSBA mandates building enclosure commissioning, and we were able to put in an air infiltration test, which is something Passive House does in the project, which cost around or less than $10,000. We did a super insulated, not super insulated, but very well insulated, not close to net zero, but not exactly net zero. And it passed the testing at 0.06 CFM per square foot. I'm looking at Michelle because she knows that's very close to Passive House. So this, and with good trades and a really good construction manager, design, bid, build, we did it. So I think this is very doable. That's what I'm going to leave it with. And I'm going to turn it over to Rick Ames from Rick Ames Architects.
All right. So, yeah, a little gruesome. We'll see where we go. Here we go. So, youngest of 4 boys. Parents were, parents were technical and artistic, but youngest of 4 boys, so I was probably exposed to things I shouldn't have been earlier than if I was fell elsewhere in the line. But early memories of, this stuff, this aspirational space age technology is going to save us. And, it was pretty cool in your jammies. And sort of started to reach consciousness in an age, born in California, raised in Connecticut and Vermont, really some really aspirational stuff going on when I was young and just finding a way and, undergraduate in Vermont and trying to figure it out. Jimmy Carter putting solar panels on the White House and technology, again, really some pretty outrageous stuff being done. I helped put the new roof on that. I wasn't of the original generation, but Bill McClay was mentioned. He lived here, early mentor. And there's moving things around and all solar. And there was a back-to-earth piece of it that was, important. But there was also a off-grid self-sufficiency that, although radical, was, I think, very collective and very communal. And people letting it fly, people trying all sorts of things to get these buildings, solar hot dog cooker, and, it was, Arcasante. The stuff up above is aspirational. The stuff below is built things I have some relationship with, just to frame it all. The lost years included me. There was a decade there, wandered off, did a whole bunch of stuff. Reagan took the panels off of the White House. Settled down, went to school, moved to Boston to get an architecture degree. 93, almost moved to Europe to work for a professor, Gunther Banish, who changed the direction of my life by both talking about modern humanistic architectural design and the height of postmodernism, but also this humanistic piece really sort of relentlessly integrated environmental components and humanistic components into the buildings. So I didn't end up making that leap, but was partially involved in this building here. And if you ever want to look at a historic, really green building, the IBM Forestry Institute in Wageningen, Netherlands, 1993, passively ventilated with these Dutch greenhouses. The sort of, these greenhouses covered these interstitial spaces that were these green, winter gardens, untempered, that passive ventilation into the offices. It had stack effect going. These gardens were purifying on-site contaminated soils right within the gardens that were in the green. I mean, it's still a benchmark to me. I don't really know how they pulled it off. But it was the first time I saw something where there were architects, engineers. Tony McLaughlin, an engineer with Borough Happold, would roll out, trace, and draw over the architectural drawings with no regard and say, this is what you have to do with the section to get this to work. And, you know, it was the first time I'd seen an integrated team in action that totally changed the caliber of way a building could work. They also only served bratwurst, and it was really grim in the winter, and my wife-to-be, it didn't work. We didn't stay. We came back, and we did design build. But, you know, the bug was there, and it became more focused, I would say, in energy than human experience, and these are sort of early, late 90s stuff where, you know, panelized with double wall, pretty cool. Zero stormwater off-site, you know, just beginning, the pieces were forming, but this stuff was going on too. You know, it was interesting to be involved with early, the transition from Energy Smith, some people remember, to Energy Star, as far as an energy system for buildings. And we did one for Energy Star, and then the Public Health Department in Boston got involved. And we did another one, this is early, probably 2000, that actually work with public health to have no toxicity and have a different spec while still trying to meet this early energy notions. And it was the first building, the transition between the two was a much tighter envelope, and we introduced ventilation. And that was it was basically better, you know, extreme bath fans coordinated with timers, but it was happening because we knew we were making an envelope so tight that it wouldn't meet these public health criteria. We went overboard. I don't think Jim is here, but Jim Newman, we worked hard on his house to make it this solar. It had a way, you know, the next round had this double wall, not nearly as much glass, so that was a good science experiment. But it was an interesting process. Energy became much, much more intensive, I would say. So we're after, you know, 2010, a little earlier than that, the Genzyme Center. Banish came back over here. That was a great thing. Reinvented the office, whole different scale. But very interesting throughout, you know, we reduced the energy 38%, but ultimately the building, the reason that like, and it has zero fossil fuel. It's from waste steam from the power plant next door, so it has steam heating and cooling. A lot of very, you know, huge daylighting system that was probably over the top, even for the time. But it was also integrated, again, this humanistic design piece that Banish brought, that there was an atrium, and there were these villages throughout the atrium, and how that coordinated. Really, looking out the window became much less and more interesting than what was happening in the atrium. And this whole feeling with the chandelier of moving under trees in a space inside was pretty radical. You know, this 2012, we did our first electrical, you know, all electric building house. These things were starting to always have exterior insulation. We were tightening up the envelope, triple glazed windows. Really beginning to feel like we had the energy to a point where we could do this all electric. You know, at that point, this house suffered in the winter of 2015. It hadn't, the heat pumps, cold climate heat pumps were on the edge. You know, it had some resistance backup in there that had no fossil fuel backup. They were brave. The technology has moved, even in 5 years, significantly past where it was at that point, and it was a risk. You know, this is the first zero energy. There's a little publicly procured greenhouse for Greenfield Community College. Deep energy sort of envelope, only south and east glazing. A lot of work for stack effect and passive ventilation. Huge array on the roof and back for powering it off. Pretty successful, pretty interesting, especially on public procurement, if anyone's aware of that. But aspirationally doing some work in Asia that, you know, was fashionable to these high-paid competitions for high sustainable buildings. Also got a very interesting high school thing that some people in the room were involved that almost got to the finish line for renovating a high school to have 8 different facades so the kids could track the energy use of the different building systems down in Dighton Rehoboth. Real, very interesting progressive project to where we, jammed signs. The integrated thing really took off. From 2010, I think it became sort of standardized practice right around that time, 2008, 2007. A variety of projects. Harvard Science One, which was a passively ventilated lab building with Banish. It went on hiatus for a decade. Some other competitions that were pretty significant. Early passive house conversations with people who later bid in. Some people here know the end result of that project. But also really interesting, all SIPs. We're moving away from foam, but this was an all SIPs, unbroken house built by Youth Build, all electric systems, LEED Gold, should have been LEED Platinum, paperwork hard with Youth Build. The solar decathlon building, we worked with Tufts and BAC in 2009, again, really low energy use. And starting to move into the much more typical 7 room, 2-family, recladding it, putting solar on it, putting all electric systems. So this is 2014, 2015. Even taking a step further back, a prototype for Hannaford, low energy, daylit building, LEED Platinum. It's all electric. We gathered all of the heat rejection in a pretty interesting system, had all the cabinets fed by coolant and not their own compressors, and we get all of the space heating, all of the hot water, and a bunch of snow melt that's in Augusta, Maine, from the rejection from the what they have to run 24/7 for heat, for cooling, for the refrigeration system. No direct light on the lettuce, but we got through a pretty interesting daylighting system. They reclaimed a mill for their trellis. They went, but it was interesting to see. It's an all electric building. It's 10 years old, cranking along. There is a gas range, and there are probably 3 gas ranges, so I should say that. But the space conditioning, that gas range is a tough one. It's going to be the last thing to go. And then, where we are, I would say now, which is very interesting to us, is public housing. DHCD is just incredible. We're recladding buildings. We're we're doing all electric buildings for DHCD. The Living Building Challenge has come in, which is a pretty cool standard for regenerative design. This has got mashed. But, this is a standard that says the building has to give back more than it takes. It's not just energy, but water, social equity, a whole urban agricultural component to it, a whole required recycled building material to it, toxicity piece of it. So this is 2015, or one of the first certified, but certainly first certified in Boston. And, these other aspirational projects going on, Plymouth Academic Campus rumbling to some fitful completion someday. This is Roaring. This is a Living Building Challenge, fully certified building for Audubon. But on some level, more importantly, is here. Tom and Jen's house down here. Yeah. But, it's gone all electric this year, and is painfully restoring a historic building that has ancient windows, redoing them with storm windows, figuring out how to do this air sealing without trashing the historic detail, and is on an arc to get there. But the other part of it is this is another one in Somerville, Meredith Elbaum, who's another hardcore, but, they've taken a Victorian completely off of the grid, induction stoves, doing all of that. And the controls have really gotten very simple. I mean, you add a Nest to this, the controls have really gotten remarkably available to how to manage one of these. And this is in Roxbury. This is a warehouse retail facility, recladding it, going all electric, has a great roof for solar, will truly be energy neutral or net energy or whatever we want to label it. And these are, central urban, pretty humble, standard housing types all over everywhere that are some taking a longer arc to the deep energy, some going quicker, but realizing that it's just not that big a deal. And so I think, I know I'm over, but this, this is being done in Hopkinton. They've got an FAA license for an autonomous 6-person drone taxi. No, I mean, they have an application into the FAA. They say they'll take you for a spin, and we're there. We're there. We're technically, it's just not an issue anymore. And that's why I applaud the political part. So there you go. Yeah.
If anyone wants to stay with questions sort of informally, I think that's how we'll do this Q&A. And also speaker bios, for anyone who's interested in hearing more, are in back.